Wonderful. So what we've done so far has been to look at games where each person makes their decision simultaneously. In other words, where I decide what I'm going to do after seeing what you decided you're going to do, and vice versa. But there's other circumstances where two people might have a strategic interaction where one person's decision is made in reaction to the other person's decision. In other words, one person chooses first, then the other person chooses second. So I want to take a look at those situations, right? And think about a couple things. Like, how does the fact that decisions are made sequentially matter for game theory? And does it matter who decides first, right? Who moves first? So to think about this, let's imagine that you've got a brilliant invention, let's say the mop sock, and you want to take it to Shark Tank, right? Take it to a group of investors. So you make an offer, right, to the investors that you'll sell 50% of your company for $100,000. And you tell them you're going to work really, really hard on this thing, right? If you work full time, really pound away, you think you can make it $250,000. With the investment. The only problem is, you currently got a day job, right? If you keep the day job and only work on the mop sock at night, then it's probably more like $150,000 you can get, right? Okay. So this leads to two decisions, right? First, the investor is going to decide, do I give you the $100,000 for 50% of your company? Then after they've made that decision, you'll decide, do I quit my job or not? So let's think about this. Do this by drawing out this sort of a decision chart, right? So the investor has a decision first. Do I invest or do I not? Once the investor's made that choice, right, you decide, do you quit your job or do you keep your job? So if you decide to quit your job, your company's going to make $250,000. The investor is going to get $125,000 of that, right? You're going to get $125,000 of that. The investor's out the initial $100,000, so they're going to make $25,000 on their investment. You're going to make $125,000. Right? On the other hand, if they decide to invest in your company and you keep your job, then the company's only going to be worth $150,000, right? You're going to split that 50-50, even Steven. So they're going to get $75,000 back after giving you $100,000. They're going to lose $25,000. How about you? Well, you're going to get your $75,000 from the company, plus you're going to keep your day job, which let's say earns you $80,000 a year. So you're going to get $155,000. Okay. How about if the investor decides not to give you any money? Well, in that case, if you quit your job like a fool, despite getting no investment, right? The entrepreneur gets nothing. Nothing offered, nothing gained. You get nothing. You're broke. Indigent. On the other hand, if you decide not to quit your job, right, the investor still gets nothing. But in this case, you at least get to keep your job, right? You get your $80,000. Okay. So these are the payoffs, right? These are the opportunities, the choices, and the payoffs. How are we going to figure out what happens? Well, if the investor knew what the entrepreneur was going to do in each of these two circumstances, then they could decide whether to invest or not, right? The problem is, whether investing is a good idea for them depends on whether the entrepreneur is going to keep their job or not. However, when the entrepreneur is given a decision, they know exactly what the investor decided to do. So what we can do is solve this via a process called backward induction, which is to say that we start with the last decision made, figure out the best decision in each circumstance the entrepreneur could find themselves in, and then once we know what the entrepreneur is going to do, figure out what that implies about the investor's best decision. So in this case, right, let's imagine the entrepreneur has gotten the investment. They have a decision. Do I quit my job and make $125,000, or do I keep my job and make $155,000? Clearly, they're better off keeping their job, right? So as a result, the investor knows if the entrepreneur gets a deal, they're going to make $155,000 by keeping their job. The return here is going to be negative $25,000. How about if the entrepreneur wasn't given an investment? Well, in that case, right, we know that quitting their job is going to be worse than keeping their job. So the entrepreneur is going to decide to keep their job still. The investor's outcome is going to be zero, right? So now the investor has a decision. Do I make an investment that I expect to lose me money, or do I not? The investor is going to decide not to make an investment. So what's happening here, despite the fact that everyone would be better off if the entrepreneur quit their job and focused entirely on the company, if the investor has to make the investment first, right, they're going to expect that that's not what will happen if they've already thrown the money out. This is essentially another version of the prisoner's dilemma, right? We have this problem where the entrepreneur is better off quitting their job or keeping their job, regardless of the decision. So as a result, we can't get to the Pareto optimal outcome. Okay, so how could we change this story, right? How could we get to a better outcome? Well, let's imagine that all the payoffs were the same, but instead of the investor moving first, we had the entrepreneur move first. In other words, the entrepreneur decides, do I quit my job or keep my job before I ever walk into this investment meeting with my investors? So now the entrepreneur decides first, right? Do I quit or do I keep? Then the investor observes this, right? Finds out whether they quit their job and decides, do I invest or not? Right, the outcomes are going to be exactly the same. If the entrepreneur quits their job, the investor invests money, the investor is going to get $25,000, the entrepreneur is going to get $125,000. Right? If the entrepreneur quits, the investor doesn't invest, then they both get nothing and they're very, very sad. Entrepreneur keeps their job, the investor invests, the entrepreneur would get $155,000 and the investor would get negative $25,000. If the entrepreneur keeps their job, the investor doesn't invest, entrepreneur gets $80,000 and the investor gets nothing. Okay, so we'll solve this again using backward induction, right? Except now the investor makes their decision knowing whether the entrepreneur has quit or not. So if the investor sees that the entrepreneur quit, what's their best move? Well, they'd rather have $25,000 than have nothing, right? They're going to want to make this investment. So their best move is going to be to take the investment, which means that the return to the entrepreneur of quitting is going to be $125,000. How about if the investor sees that the entrepreneur kept their job? Well, in that case, they're going to decide, do I want to lose $25,000 or do I want to walk away? They're going to want to walk away. So the entrepreneur is going to know that keeping their job is going to have a return of $80,000. So is the entrepreneur going to quit? Yeah, right, because they'd rather get $125,000 than $80,000. The entrepreneur is going to quit. This is going to be our outcome, right? We're going to get an investment with the entrepreneur quitting their job. So how did this happen? Because the entrepreneur essentially committed to some action, right? Committed to not taking the job, not keeping the job, by quitting before the investor had to make a decision. And as a result, the timing of this sequence, right, who moves first and who moves second, was able to determine the outcome. Now, of course, in the real world, right, there might be a little bit of uncertainty here. So if you're an entrepreneur, you really have to know the investor's payoffs to decide that you're going to quit ahead of the meeting. If you weren't sure whether the investor was willing to make an investment or not, even if you quit the job, then you'd be a little bit reluctant, exposing yourself to the risk of walking away penniless. But this isn't going to be a concern if you know the investor's payoffs and the investor knows your payoffs.